In this video, we are going to answer some of the questions in Math Reviewer. So let's start with number 15. Number 15, perform the indicated operations of 6 minus negative 2 over 2. So in this situation, it is expected that we are going to use the four basic operations, which is the addition, subtraction, multiplication, and division. So for this, 6 minus negative 2 over 2, since there is 2 negative here, we will multiply negative times negative. So this will become 6. Negative times negative, it will become positive 2 and over 2 equals 6 plus 2 equals 8 over 2. So 8 divided by 2, the answer is 4. For number 51, what is the remainder when 5 raised to 34 is divided by 17? So in this question, we are going to find the modulo. So what we will do is 5 raised to 34 is equal to, now we will think of a number that will be multiplied that will result to 34 or to the nearest number, which is 34. So we have 5 raised to 16 times 2. So we have 5 raised to 16 times 2. We have 5 raised to 32. So we still have the remaining 2. What we will do is multiply here 5 raised to 2 mod 17. Next, so this will become 1 times 5 raised to 2 mod 17. So 5 raised to 2 is 25 times 1. So we have 25 mod 17. So the answer is 25. However, since 25 is greater than 7, it means that we can still find its least mode. So 25 divided by 17, the answer is 1.47058. The next thing we will do is minus this 1. Then the answer, so the result is 0.47058. Lastly, 0.47058 multiply to our mod 17. So that will result to 8. And the answer is 8. When 5 raised to 34 is divided by 17, the remainder is 8. So for number 87, what is the simplest form of 1/2 raised to negative a times 8 raised to negative b? What we will do first in this expression is express this one into a positive exponent using 1/2 raised to negative n be equal to a raised to n. So 1/2 raised to negative a will become 2 raised to a times 8 raised to negative b. Express these terms with the same base. So 2 raised to a times 2 raised to negative 3b. So 2 times 2, 4 times 2 is 8. So we have now the same base. Next is multiply this expression by adding the exponent. So this will become 2 raised to a minus 3b. So this is our final answer. The simplest form for 1/2 raised to a times 8 raised to negative b is 2 raised to a minus 3b. For number 195, the distance a that a spring is stretched by an object varies directly as the weight b of the object. If a 15-gram object stretches a spring 8 meters, how far will a 40-gram weight stretch the spring? We can set up a proportion to solve this problem since the distance that a spring is stretched a varies directly with the weight of the object b. So we can use the formula for direct variation. A over b equals to k, wherein the k is our constant proportionality. To solve for k, we can use this information. 15-gram object stretches the spring rather, for about 8 meters. So A over B equals to K. Now that we know K, we can use it to solve for the distance stretched by a 40-gram weight. We have here 40-gram weight. So now we can derive a formula which is A over 40 equals 8 over 15. So this will become A 15 equals 320. In order to get the A, we will divide both sides by 15. So cancel this one. Our A is 21.32. Therefore, a 40-gram weight will stretch the spring approximately 21.32 meters. So this is our final answer. For number 123, the problem is simplify the square root of 72x raised to 4, y raised to 5, and z raised to 6. Now what we are going to do first is factor out the 72 and wherein the other number is a perfect square. So we will think of a factor wherein the other number is a perfect square. So 72 we have 36 and 2. We will just put square root of 36 times square root of 2. Then factor x raised to 4, we have x raised to 2 times x raised to 2. Then, y, factor out y raised to 5. We have y raised to 2, y raised to 2, and another y. Next is factor out z. So we have z squared, another z raised to 2, and z raised to 2. So we have z raised to 6, since we will just add the exponent. So now let's simplify. Square root of 36 is 6. Then, what we are going to do with our exponent of the variable is divide with the index 2. So, our exponent is 4 divided by 2, we have x squared. We will just copy the variable. Next is the exponent of y, which is 5, divided by 2, we have also 2 and a remaining y. So y squared. Next is z. The exponent of z, which is 6, divided by 2, we have z raised to 3. So, since 6 divided by 2 is 3. So, we have z 3. Then, we have the square root of 2. Since we cannot simplify square root of 2, we will just copy square root of 2. Then, the y, we still have the remaining y. Since 5 divided by 2, there is a remainder 1. So, we will just copy inside the square root the y. So, we have here the final answer, which is 6x squared y squared z cube square root of 2y. So this is the simplest form of the square root of 72 raised to x 4, 72x raised to 4, and y raised to 5, z raised to 6. The answer is 6x squared y squared z cube square root of 2y. For number 159, find the solutions of the quadratic equation x squared minus 5x minus 10 equals 0. So in this problem, we are going to use the quadratic formula, which is negative b plus minus the square root of b squared minus 4ac over 2a. So in this equation, we will find the value of a, b, and c. Our a is 1, b is negative 5, and c is negative 10. Now we will just follow the formula by substituting the value of our a, b, and c. So this will become negative times, since it is in the formula negative b, negative times negative 5 plus minus negative 5 raised to 2 minus 4, and our value of a is 1 times c, which is negative 10, over 2 times 1. Negative times negative 5, so it will become 5 plus minus square root of 25, which came from negative 5 raised to 2, and that will become 25. 4 times 1 times negative 10 is equal to negative 40 times the negative here, so it will become positive 40 over 2. Simplify this one. So our x sub 1 is 5 plus minus the square root of 65 over 2. Or our x sub 1 is 5 plus square root of 65 over 2, or x sub 2 is 5 minus square root of 65 over 2. Or we can write this one as simply as this: 5 over 2 plus or minus square root of 65 over 2. So our final answer is 5 over 2 plus or minus square root of 65 over 2. For number 195, the distance A that a spring is stretched by an object varies directly as the weight B of the object. If a 15-gram object stretches a spring 8 meters, how far will a 40-gram weight stretch the spring? We can set up a proportion to solve this problem, since the distance that a spring is stretched A varies directly with the weight of the object B. So we can use the formula for direct variation: A over B equals to K, wherein the K is our constant proportionality. To solve for K, we can use this information: 15-gram object stretches the spring for about 8 meters. So A over B equals to K. Now that we know K, we can use it to solve for the distance stretched by a 40-gram weight. We have here 40-gram weight. So now we can derive a formula which is A over 40 equals 8 over 15. So this will become A 15 equals 320. In order to get the A, we will divide both sides by 15. So cancel this one. Our A is 21.32. Therefore, a 40-gram weight will stretch the spring approximately 21.32 meters. So this is our final answer. For number 231, a trapezoid ABCD is given where triangle DAB is congruent to triangle CBA. Which of the following statement is true based on the given information? So for the option A, it says that segment BD is congruent to segment CD. And for letter B, segment DA is congruent to segment DC. And letter C, angle BCE is congruent to angle DAB. And the letter D, angle ACB is congruent to angle BDA. So if we were to draw an illustration or a trapezoid named as A, B, C, D. Let's draw a line here, A to C and B to D, in order to create a triangle. So for letter A, it says that segment BD is congruent to segment CD. So segment BD is congruent to segment CD. So for letter A, it is wrong. Let's try letter B. Segment DA. So segment DA is congruent to segment DC, which is actually incorrect. For option letter C, angle BCE, let's see, this is our angle E. Angle BCE, so this is our angle, is congruent to the angle DAB. So this is also incorrect because angle BCE is not congruent to angle DAB. So for letter D, angle ACB is congruent to angle BDA. So this is correct. The angle here and angle here is actually congruent. So the correct answer is letter D. Angle ACB is congruent to angle BDA. For number 261, the problem is, a carpenter was requested by his son to construct a wooden cube that is 5 cm on his side. How much wood was used? So in this problem, we are going to find out how much wood was used in order to construct a wooden cube. So in order for us to construct a wooden cube, we are going to get the volume of a cube. The formula for a volume of a cube is A raised to 3. So our given is 5 cm. So 5 raised to 3 is simply 125. So 125 centimeter is the 125 centimeter is the needed wood in order to construct a wooden cube. So the answer is 125 centimeter. For number 303, simplify sin y plus sin y cotangent squared y. We can simplify this expression by factoring sin y. So sin y plus sin y cotangent squared y is equal to sine y times the quantity of 1 plus cotangent squared y. Recall the Pythagorean identity. Cotangent squared y plus 1 is equal to cosecant squared y. So we can rewrite this expression as sine y 1 plus cotangent squared y is equal to sine y cosecant y, cosecant squared y. Therefore, the simplified expression is sine y cosecant squared y, which can be further simplified to cosecant y. So the final answer is cosecant y. For number 339, the problem is there are 2 and 4 possible routes going from city A to city B and from city A to city C respectively. Going to D, there are 4 and 5 routes from city B and C respectively. How many possible ways are there to go A to D? To get from city A to city D, we can take any of the routes from A to B and then take any of the routes from A to C. Or even any of the routes from A to C and any from the routes from C to D. Therefore, the total number of possible ways to get from A to D is the sum of the number of ways to get from A to B, city E to city B, and then to D, plus the number of ways to get from A to C and then to D. So, number of ways from A to B times number of ways from B to D. Plus number of ways from A to C times the number of ways from C to D. So from A to B, there are 2 possible ways, and B to D, we have 4. So we have 2 times 4 equals 8 ways to get 8 ways to get A to D. Then also A to C, we have 4, and C to D, we have 5 possible roots. So there are 4 times 5, which is 20 ways to get from A to D through C. Ways to get A to D through C. So this one is through B. Therefore, the total number of possible ways to get from A to D is 28, since we will just add 8 plus 20, which is equal to 28 possible ways to get from city A to city D. So this is the final answer. For number 375, Aldwin, Alex, Dale, Daniel, and Vermin are psychologists, testing whether a series of workshops on assertive training increases eye contacts initiated by shy college students in controlled interactions with strangers. A total of 32 subjects are randomly assigned, 8 to a group, to attend either 0, 1, 2, or either 0, 1, 2, or 3 workshops. The results expressed as the number of eye contacts during a standard observation period, with which F-test must be used. Letter A, 1 factor with measures on different subjects. And for letter B, 1 factor with measures in the same subjects. And letter C, 2-factor analysis of variance. And letter D, F max test. So for this study, to test the effect of the assertive training workshops in the number of eye contacts initiated by college students, a two-way analysis or 2-factor analysis of variance must be used. Since the independent variable in this study is the number of workshop sessions attended, 0, 1, 2, or 3, and the dependent variable is the observation period. So the answer is letter C, 2-factor analysis of variance. For number 447, the problem is, suppose a certain car supply a constant deceleration of a meter per second. If it is traveling at 25 meter per second, when the brakes are applied, its stopping distance is 50 meters. So what is A? The option is, for letter A, 6.35 millimeter per second, B, 6.45 millimeter per second, and C is 6 meter per second. Letter C, 6.15 meter per second, and D is 6.25 meter per second. So in the problem, we will use the kinematic equation, which is v squared equal to u squared plus 2as. And wherein our v is the final velocity and the u is the initial velocity and a is the constant and s is the stopping distance. So for our final velocity, we have the given 0 meter per second, and our initial velocity is 25 meter per second, and our A as the constant deceleration is what we are going to find and the required in the problem, and our S is the stopping distance, which is 50 meter. So what we are going to do now is just substitute. So our V is 0. 0 squared is equal to, our U is 25 squared plus 2, and our A is, we don't have the given since it is the required in the problem, so we will just copy A and times the S, which is 50 meter. Now simplify this one, which is 0 is equal to 625. 25 raised to 2 is 625 plus 2 times 50 is 100, and copy A. Now we will just divide both sides by 100. So cancel this one. Our A is negative 6.25, or get the absolute value, which is 6. Since we are talking about the distance, the negative answer will become 6.25. So the answer is 6.25 meter per second. For number 483, it is the period where the importance of mathematics and science engendered a new mathematics culture, where heavy emphasis was given to the proper instruments for measuring, observing, calculating, and recording information. So, for letter A, 18th century, B, 17th century, C, Renaissance period, and D, 16th century. So in the history of mathematics, the period where the importance in science engendered a new mathematics culture, where heavy emphasis was given to the proper instruments for measuring, observing, calculating, and recording information, is the 17th century. So the answer for this question is letter B, 17th century.